And whenever you type in the chat, just raise your hand so I get to it. Um so here we go. Now that this potentially could be a 10-mark question in your midterm, this number 5, and we just spent how many? Like 30 seconds organizing our thoughts and trying to see what exactly do we have. And even though we didn't get to the code yet, this step is just going to simplify the process so much. It's going to save you time. Okay? And so what are we? Okay, we have the inputs, we have the outputs, and we want to know, and this is our function, and we want to know, uh, we want to test your function with arrays of different length and with varying number of twos. The function should return the number of twos in the array. Okay, so we should count the number of twos. Now, counting, that means we have to, like, if we think about it now, we're thinking, so we have to loop or go through the array one by one and see if each element, so now we're like dissecting the problem. So go over every element. If it's a two, we count it, add one to the count. If it's not a two, we do nothing. And it did not specify how the function, okay, test your functions with arrays of different length. It did not specify, like, is it like the user who provides the input or what? Like, they didn't specify that part. But yeah, now we're pretty much done. So let's get to the code. So I'm gonna, you can do this in Visual Studio. I'm just using my terminal here. So programming, this is problem 5.c++. Okay, I'll be writing on the left, and we're gonna be running the code on the right. And don't be scared of that setup. That's just my programming setup. So we're gonna do include IOStream. Okay, we must include the functions and things we're gonna be using. We're gonna go the use namespace std, so we don't have to write stdc out and cn every time. And we're gonna have main. So we have void. I don't know, how do you guys like define main in your course? Do you do void or do you do int?
Int.
Okay, so let's do it the way they do, and we just return a 0 to say that there is no errors. That's pretty standard. Now, from our diagram, you could have this. Oops. From our diagram, you could have this done on a paper. It's almost pretty much done. Like the function signature, everything is just told in this. Like the whole story is told here. So count num twos. Okay, so that's our function. What was it going to return? It's going to return number of twos, which is also, let's put the type here. So it's going to be an int. So I'm going to have a function. So it's going to return an int. So it's going to start with int. It's going to say count num twos, and that's my function. Now I just put two things. I put the output and the output type, and I put the function name. Now I need to pass in these two because it's going to take these two inputs. So let's, like, exactly like the way they mentioned it. It's going to take an int of an array of ints. So is that how we do it? Someone tell me. Int array, or should we do this? Which one is it? Which one is it?
The first one's correct.
Okay. And we have the size because when we pass, did you guys take pointers?
Not yet.
Okay, not yet. Okay, cool. So array is going to be the pointing, let's not say pointing, but it's going to represent the first element, and we pass in the size because we don't know the size beforehand. The function has no clue on what size it is, and that's why we have to pass it. So now let's have, we want to count the twos, okay? So before we do anything, like, where are we going to count them? Like, we need a place to count them. So we'll have an int. Is actually going to be the final thing that we return. So, and it's going to be number of twos. I think that's a meaningful name. So number of twos. It's okay to have long variable names as long as they make sense to you. And it makes sense to initialize it to 0. Okay. And before I forget, this function returns an int. So I want to make sure that I return this number of twos. Okay. And don't forget the semicolons, otherwise, like, you're gonna be messed up. So now we pretty much have everything, like the whole structure, the whole skeleton of the function. put down. So we have the thing that we're gonna start counting in. We have the thing that we're gonna return, and it's an int exactly. So it's an int, just like the function type, the return value. This function gives us. And now what's left is actually doing the counting and modifying this. Otherwise, we're just gonna return zero if we call it this way. It's gonna number two is zero, and it's gonna return a zero. We have a question. Go, Khadija.
But why do we have to initialize number of twos as zero?
Because now um, logically speaking, if we have an array that it may contain twos, it may not contain twos, but we don't know yet. We haven't looked through it yet. So I would assume that there's no twos, and then if I encounter a two, I'll just add it. So I will count it if it exists. If it doesn't, then there's zero by default, right?
Okay, yeah, that makes sense.
Okay. So now let's start the loop. So loops are pretty standard. You just this one is no brainer, no problem solving. You should memorize this. So the syntax for a loop that should be memorized. So for int I equals zero, we use I by convention. That's what we use usually, and we have I. And okay, now this is the important part. We want to make sure that we loop to the right limit. We don't want to go to exceed. We don't want to go below, right? So I'm gonna go I till someone tell me what should be here. What should we have here? So when are we gonna stop?
Two, right?
Nope. So we're gonna count as many elements as in the array. We're gonna check the entire array. So what are we gonna do?
So how much arrays
So
are there? I mean, how much elements are
what
there?
what variable here that represents the length of the array? Do you have something here, some variable here that represents the
Size.
yeah, exactly, size. So we particularly have this input given to the function because to tell the function what size it should stop at, or like how many elements it should count. So we have okay, I starts at zero till size, and then I plus plus. Here we go. And now we have all the magic has to go through inside this function. So I'm gonna do what I want to do first is I want to get the element of the array, the current element at this index. So I is going to go from zero all the way to uh, like size minus one, right? So if we have an array of 5 elements, so array, so for example, let's have a comment here. So array that contains 1, 2, 3, 4, 5, it's going to have a size. So like when we pass it to this function, it's going to have, I'm just like writing, let's zoom in, and it's going to have a size that's equal to 5 because we have 1, 2, 3, 4, 5 elements. Now, the indexes, so the first, so this is, let's call this I, okay? And we call this array I. So I is being the index, and array I being the value at that index. So the values at our in our array are 1, 2, 3, 4, 5, and the indexes are going to start from 0, 1, 2, 3, 4. Okay, so they're going to go from 0 till 4. This is I. And that way we're gonna, so when like when we get array 0, that's going to be 1. When we get array of 1, it's going to be 2. When we get array of 2, it's going to be 3. When we get array of 3, and so on. Is that fine? So I'm going to say if I want to check if it's a 2 or not, because if it's not a 2, I don't want to count it. I can't just like say number of twos. Oops, twos plus plus. That's incorrect. I'll be like counting every element as a 2, even though it's not a 2. So I'm going to do if. I want to check. So whenever we check, we use conditional statements or if statements. So I'm going to say if array I, so if the element at the index I, that's what this says, I want to check if it is like I want to count it. So that I'm going to count it if it is equal to 2. Exactly. And right here inside the if, I'm going to say if it is equal to 2 indeed, I'm going to increment my count, the one I'm using to keep track of 2. So I can use plus equal 1, or I can do plus plus. I like plus plus. It makes more sense. And that's it. Now what this says is go through every element in the array. So like in plain English. In plain English, count number of twos is a function that returns an int. It takes in an array and it takes in the size of that array. It assumes, or like it tracks the number of twos in a variable called number of twos. Initially it's zero because we have no twos yet, we haven't started looking, and then it loops, because a loop is whenever we want to go through or iterate or do something multiple times, we do a loop. So we want to track or we want to check every element in the array. So we have this, it's pretty standard syntax that we use when we want to iterate over arrays. We start from zero all the way to I less than size, because we want to stop at the very last element, and then we increment the index. So that's standard loop. And then if that element is a 2, we check for every element using this syntax. We check if it's a 2, we increment the 2s. Otherwise, we do nothing. We don't even need to explicitly say else, because if it's a 2, we increment. Otherwise, nothing. And then by the end of this loop, so after this bracket, this loop has been complete, we return the number of twos that we have encountered so far. So let's test this. Okay, this looks cool. Let's test it. So he said, test your function with arrays of different length with varying number of twos. So do you have examples where you have this, like the array defined already in the code, or do you have to take it from user input? Like, what does he usually do? Should we use CEN and take it from user input, or like you can have something like array, for example, is equal to 1, 2, 3. Can we do that? Is that something that we can
I
do?
think we can, but like we also do like user input. So I think for this one,
Okay, especially because he didn't specify, so let's do it with user input. And he said test the different functions. So I'm going to say int n, which is going to be like like int size. And I'm going to say cout, please enter the size of the array. And that's it. And I'm going to do cn and take in the size. Okay. And I'm going to have an array. So once he gives us the size, I'm going to create an array dynamically. So I'm going to say int array. So did you take the new keyword? New array. Did you guys do this, like new?
no, we didn't.
I don't think so.
You did. So size has to be constant, or it can be given by the user. I don't want to like. Okay, so you didn't do new. Okay, so I don't know what examples did he give you in terms of. So usually he did something like this. So would it be something like this?
I thought like from the question that we had to like get the input and then count how many elements like we make the like whole program. So that's what I tried to do.
Let's see. So usually it's fixed. I see. So usually it's fixed. So generate 10 numbers. 4 scores. Okay, so it's always fixed. Converts a binary
Yeah, I think
number.
it's constant. Constant, or you can do
Okay,
like
so it's
the size,
always fixed. Okay.
or you can do like int array 5 like that.
Okay, but you have no instances where like the user inputs the size and you create an array when he inputs it. Yes or no? Because it's a different thing. Okay, I'll just keep it constant for now.
See
So,
that, yeah.
okay, good. That's even easier. So okay, so we have a size. Maybe if, it's equal to 5, and we're gonna have an array. So int array is gonna be up to size, and it's gonna be uninitialized, nothing there yet. And same loop. So you should memorize this by now. I less than size. It's called size here with a capital, and I plus plus. And here I'm going to say that I'm going to cn. Let's actually tell him first. So cout enter maybe make it friendly. So enter size numbers. So like it says enter 5 numbers. And here we're gonna do CIN, and we're gonna put it into the array. Okay, that's how we take the user input and put it into the array. Let's actually zoom out so you can see the whole thing here. Now that the user inputs the array, let's test it. So I'm gonna say int twos. This is some other variable, so I can capture the return output of count nums. Or we can actually, we don't need this, so I can just like say cout and directly say we found and count. So we're gonna call the function count num2s. And what do we need to give it based on our diagram? Takes an array, takes a size, and that's exactly what we're going to give it. So we're going to give it an array, we're going to give it the size, and make sure like when you're calling the function, you call it with the variables within that area. Okay, you don't call it with these names. So you don't call it with array and the small case size. These are unrelated. It's just a coincidence that I have the same name, ERR and ERR here, but they're different, right? So I'm going to call it with the variables I have here. So array, I'm going to give it the array, and I'm going to give it the size I have here. And now inside the function, you can call it whatever and deal with it as whatever. You don't care about the name of the variable. We found this many twos. Okay, and let's add like a new line, end line. And yeah, I think that looks correct. Let's see. So we save that and let's run it. Oops, this is, I'm just gonna compile it, and it's gonna call problem 5. So problem 5, and we're gonna problem 5.0. Okay, and we run it. Don't worry about this part. It's something else. So problem 5.0. Okay. Okay, so it's we compiled it and we're running it. Enter 5 numbers. We're gonna enter like 1, 3, 2, 2, 4. We should have, and that's like maybe another 2, sorry. And let's enter, and we get the correct output. So we found this many 2s, 3. Are we good? Any questions? I want to hear questions. There are no stupid questions.
I
I
don't
want to hear
understand.
everything. Go ahead.
So I don't understand, like, how can, like, for when you, the last line for cout, when you print it and you use
This.
it, like, yeah, you call the function. So I don't understand when we can do that and when we just like we're
So cout, good question. So cout can take an int, right? It can take a number, like we can just say something like cout number, and we can put in like 1. Okay. And if we run this, whatever, so we get number and 1 here. Okay. Now this function returns an integer. It's just like you can replace this and with an integer. It returns an int. So if we call it, it's gonna, like when we give it the correct input, it's gonna return an integer, and we can just put that integer into the print, no problem. It's the same thing as if we do int twos, and we say that the twos is gonna be equal to, like let's copy this actually. So it's gonna be this, copy this, and paste it here, and let's delete that twos, and let's copy this, and we'll type here, instead of this, we'll type in twos. And let's comment this out. Okay. And we run it. Cout, we found this. So what did I have wrong? Oh, I forgot a semicolon. And again, during the exam, when you get errors, don't panic. I know it looks scary, but no, go through them and read them. They're usually like, they give you the solution right in the error message, right? So it gives you the line number. That's the most important thing to look at whenever you're compiling. And you guys use Visual Studio, right?
Yeah.
Okay, so whenever you compile, make sure to look at the line numbers. It's usually given in there. So look, 27, and that's exactly where I need to make the modification. So like somewhere around the 27 or 25, 26. So it says expected, comma, or semicolon before C out. So it's literally giving you the solution without panicking. It's expecting this semicolon before C out. So I look at C out. This is C out on line 27. And before it is this line, and there's no semicolon indeed. And we know that any line should end with a semicolon in C++. So without panicking, we solve the problem in like 5 seconds. Here we go. So 1, 2, 3, 2, 2, and we get the same answer. So, but in this case, I'm not going to be using this variable. Like I'm just interested in printing it one time and that's it. So I can just like take this, let's select this, delete it, and I'm gonna put it in here. Okay, and I'm gonna delete this. Oops. So the function returns a number. We can just print it, no problem. It's fine. But what we cannot do is we cannot do something like this. We cannot do we found this, and we can do like count num2s. Okay, why? Because in this case, count num2s is a function. It has not been called yet. It does not, like, this is not an int. This is a function. But if we do this, like if we do this and we give it array and we give it the size, now it's going to be called with the correct inputs, and it's going to return exactly what we declared it to return, which is an int. And in that case, it's going to work out just fine. If this is like not convenient for you, it's okay. Capture it in a variable first in twos, and then print it. Okay, are we clear?
Is this only when we're like returning a value, like we did return number of twos?
If we're returning a number, a value that can be printed. So if we're returning a character, if we're returning an int, if we're returning a number, a string, any of these, something that we can print or we can just like plug into a cout, then we can do that. If it's not, then we can't. Okay.
And so like why can't we use the variable number of twos to print?
We can, no problem. So that's what we did here. So int, like now in the like the other solution, there's two solutions. Either we put it like call the function and like the output, which is an int, put it into a variable, twos, and then that's what we print. We found this many twos, or without putting it into a variable first, since it already like this already returns an integer, instead of putting it into a variable first, we can just print it right away. So we put this whole thing directly into this. Okay,
Okay, thank you.
you're welcome. So is this question clear before moving to the next one? Is it all good? All good, everyone? Give me a thumbs up if you think it's clear.
That's clear.
Okay, let's move to the next one. So let's close this, and we're gonna have problem. You guys tell me which one do you want to do? Which one is most scary? 1, 2, 3, 4, 5, 6. Let me know. We can solve any, so just like whatever you think is like needs more work, let me know. 4 or 6. Okay, let's do 4. It's interesting. Okay. Okay, before I do it, I don't want to do it like on my own. Let's give you guys 5 to 10 minutes to think about it. So do the process that we just discussed. So understand the problem, read it, and then I'll ask you to like describe what exactly do we need to do, and maybe like you can dictate the code that I need to write for me, and then we can see where we had problems and fix it. Okay, that would be more useful other than just you watching me solve. Okay, so we're gonna have, now it's what? Now it's 5 6. At 516, we're gonna continue, but I want you guys to try it on your own. So that's question 4. Write a C plus program that uses functions to generate 10 random numbers between 0 and 9 and stores them in an array. Then another function should be used to sort these numbers. So two things: we generate numbers, put them in an array, and then no, you guys do you guys do the thought process. I'll be muted and we continue at when 5:15 or 5:16. Okay. Hopefully everyone worked on it. Let's move to problem. This is problem 4, right? Yes, problem 4. And that's what we're going to look at. Okay, so problem 4. What do we start with? I'm going to have the typical include IOStream. I'm going to have the using namespace std. I'm going to have int main, and we're going to return 0, the typical boilerplate. Now, what do we do? I'll be listening to you guys. Want to see how we approach this problem. So, did you do the understanding the problem part that we talked about, like dissecting it and seeing exactly what we want to do? Should I do it?
Yeah, can you do it?
Okay.
I did it, but I'm just not sure exactly of the input.
Okay. So, number 1, it says use functions. So we're gonna put everything in a function, okay? So the first function is, it's nice that the instructions are pretty explicit. So we can have use a function to do this, and then another function that does that, and it's a little bit explicit, so we know what to do. So let's dissect it one by one. Generate 10 randoms and random numbers between 0 and 9 and store them in an array. Okay. So the function stores them into an array. Okay. And did you take passing by reference, by value and by reference?
Yeah.
Okay, good. So what we're going to do is we're going to have int. What is it going to do? It's just going to generate the numbers. So it's not going to return anything. It's just generating the numbers. Generate numbers. And let's actually call it this way. Generate numbers. And what is it going to take? It's going to take in an array. Okay, so it's going to be given an array, and it's going to generate the numbers and put them into that array. So it's going to take an array. The array stores numbers, so we're just going to do this. Okay, and the size is constant. It's always 10, right? So they said that it is, they're always 10 numbers. Generate 10 numbers. Can we find like anywhere in this place that says it could be different? No, it's just 10 numbers. So that's good. So we're going to have a constant here. Like before we continue our function, we're going to have a constant int, and actually, we can still do the same thing we did before. So we can just do int size, okay? And we'll have the size defined here. So const int size, capital because it's a constant by convention. We like to capitalize constants, and that's our size. Now let's continue our number generator. It's going to take int array, and it's going to take in a size. So we want to go over the array, and for every place in the array, we want to put a new random number. So I'm going to do for the typical loop, I equals 0. Now you can see how this repeats a lot. I plus plus, and we're going to do an array I. So we want to set. We're not doing like previously we did say CEN, and we did this because we are filling the array from user input. But in this case, we're just going to set it to a random number. Is this how we do a random number? Rand? Or what's the
Yeah.
function we use? Okay, rand. And did they give us any restrictions? So the random numbers between 0 and 9. Okay. So how do we do
Don't
that?
we have to seed the rent? So we have to put S for time, right?
We could. So we can do srand, and we can do time, and we can do like give it null. Is that how you guys do it in the course?
Yeah, with the zero. Time
Use a
is
zero.
zero.
Okay. Time 0. Okay. So srand time, no. Okay, we could do that, but maybe for, like for testing initially, I would just like comment this out so we have the same numbers every time for testing, and then when it works, we can add that. So, and you can do it here. You can do it in main. Let's keep it in main actually. So srand, okay, and yeah, that's pretty much it. And we can have our array. So in main, we can have the array so array is going to be of size, and so we can say seed the random number generator, and we can have something like generate, or actually it's self-explanatory, so we can say generate numbers, call it, and give it the things it expects. So we're giving it the array, and we're giving it the size. Okay, and now after this function is called, we're gonna have like array is gonna have the new numbers that we just created. But first of all, let's read the question properly. So it says 10 random numbers between 0 and 9. So they must be between 0 and 9. We can't just have any number. So let's actually try running this right now and see what happens. First of all, I'm generating the numbers. I want to look at the array. So let's actually create, because we can't look at the array yet, let's look at what's inside the array. So it says use functions to print the elements before and after sorting. So we need a function to print, right? So I'm going to have the same thing. Now you guys like tell me what to do here. How do you print? So let's call it something like print array. And what does it take? We want to print everything in the array out. So let's go one by one. So what do we have here? Int array. So it's going to have the same format.
So it's the same thing, right? Just so we can print
Yep.
it.
Yep. So we can have int size, and same thing. I can actually copy this. So I can we can copy this, and we can paste it in here. But we're instead of random, so instead of random, we are going to put it out into cout, right? We're going to print every element in the array, and we're going to have a space, so there's a space after each of these. Okay, and at the very end, we want to have a new line, right? So we end on a new line, and we can use either this, or we can do end or like end line as usual. So we can save this, and let's see if we can run it. So it's clear. This is problem 4. So let's change this here and run it, and nothing happened. Why? Why did we get nothing yet?
We need to call the function.
Yes, so we can go all the way down here, and we can print array, give it the array, and give it the size. So, and let's actually do this so once before we generate the numbers, and then generate the numbers, and then we print it. So save it, run it, and boom, here we go. So initially, this is before the so the first print before we generate numbers. So we had 0, 0, 0, 0 10 times, which is good. And then after we generated the numbers, we have some random numbers, which are not between 0 and 9, right? So what we need to do is use modulo, okay? You probably took this, and whenever we want to generate random numbers between a range, we do modulo the range plus 1. So if we want to go from 0 to 9, not including, so maybe in the exam you might ask the professor, is it inclusive? So is 9 included or not? In this case, they want 10 random numbers, and between 0 and 9, probably they want 9 included, right? So that's what we're going to do. So we're going to do 9 plus 1, which is 10, modulo that. So that's going to give us all numbers, random numbers between 0 and 10, not including 10. So if we do this, run it again, excellent. And because we're doing the seed with the time, we're getting new numbers every single time. And don't ever forget this. Like, this is so important. They will deduct marks if they don't see the seed. So whenever you see a question random, that's pretty much the first thing you do. srand time 0. And I don't know if sometimes you might need to include, like if it's not working, you might need to include time or something like that. I'm not sure. But usually I think it should work without doing that. Or maybe like include random. I'm not sure if you have to include it. But in my case, it's fine. So now we can try this a couple of times. It's working as expected. Now let's continue, move on to the next part of the problem. And you can see how we're doing it incrementally. We're adding things to the problem as we go. And like in every step, it's working, it's working, it's working. We're continuing. And that's how we progress. Like, we don't have to do the whole thing at once. And we can even like print and see what things like, so we like catch problems early on. Now, okay, now this is the tricky part. We need to sort the function, okay? So we can have, let's actually structure it in terms of the thing they want. So, oops, so we can delete this, put it here, and we can say something like cout array before sort, okay? And we can take that, put it here, and we can say array after sort. And somewhere here, we need to do something, sort the array. Okay? And let's run this and see what we get. So we have the array before sort, and then array before after sort. It's exactly the same. We haven't done anything, but like somewhere here, we need to sort the array. And it says, oops, it says, another function should be used to sort those numbers in ascending order. Okay, so let's have a function. So we're going to call it, and it's going to use what? The sort should be done using bubble sort. So I'm going to call it bubble sort. Bubble sort. Okay, that's what we're going to do. And it's going to take, again, it's going to take an array that we want to sort, and it's going to take its size. Did you guys study bubble sort? Or is it just like, that's the first question on it?
We didn't take.
You didn't take it, okay. So I think pretty much if you're able to do this question 4, maybe 3 and 4 by heart, we should be really good for the mid. He deliberately made it a little bit more difficult, because if you didn't take bubble sort, and he's giving it in this question, so he made it a little bit more difficult. Like, he gave you the instructions to do something that you haven't seen before, but he gave you the instructions so that the midterm should be hopefully easy. Okay, but let's see. Let's take it one by one. To perform bubble sorting, you should first, so let's like dissect this. This is we want to like implement this bubble sort. We don't like, maybe it's a word we just heard about now, but that doesn't matter. We have the instructions. We're able to think about it. We have our pen and paper, and we're able to dissect it and solve it at the end. So it shouldn't be a problem. So let's go here and have that function, right? So we're gonna have a function called bubble sort. It's not gonna return anything again, because it's doing its operation on the array itself. So bubble sort is gonna take exactly the same. So int array, It's going to take int size, just like the ones before. Okay, most functions that are going to work on arrays are going to have this same signature, the array and the size. So now, to perform bubble sorting, you should compare the first element with the second element and store the max of both in the second element. Swap if necessary, use function. Okay. Then compare the second element. Did you take the swap function?
Yeah.
I think we took yes and temp.
Okay, so like swap and you give it two things and it swaps them. And I think you have to do this, right?
Like we did it like we put it in a temporary variable and then we
Oh,
swap.
okay, so you wrote it on your own. Okay. Okay, I see. So, okay, so that's what we can do. So we can have something like void swap because we need it for this function. So we need swap for this function. So we can do void swap and it's going to take two things and it's just going to swap them. Now, how do we do this? Like, do we need some special way to define this? Like, what the signature looks like? So we're going to have, would this work? Two things, or do we need something else?
Can't we just do it in the like in the bubble sort function? Like without creating.
In here? We could, which would be easier, but I think it said swap if necessary, use function. I think use function, they want us to have another function for swapping, right? I'm not sure, but I think it wants us to do the swap in a function. I'm not sure what did he tell you, but did you see this like this to pass it by reference?
Isn't this pointers or
Yeah, pointers.
no? We took reference, but we didn't take pointers.
So how do you do it? You're gonna
We just assign like a temporary variable for like the number, and then we make it equal to like we make the numbers equal to each other, and then we take the second number and put it in the temporary.
yeah.
But
So
we
you
take
do something like and temp is gonna be equal to maybe like store a, and then int a, or like a is gonna be equal to b, and b is gonna be equal to temp, right?
yeah.
But like you need to pass it by reference, right? So because otherwise,
I'm looking. Sorry, I'm looking through the slides right now. He did teach us.
okay.
So
So how
it's
do you do it?
swap and then bracket int and variable one, and then int
Okay, so
and variable,
int
and then
and
yeah, and then he did int temp equals to variable one.
okay, excellent. So that's how we pass it by reference. Okay, because if we don't have this and, then whatever we're gonna modify here is gonna be just inside this function. It's gonna be like by value, like we're just swapping things inside, but it's not gonna reflect outside on like the other function that calls it. So if we do swap, if we have like if we have int a equal 1 and we have int b equal 2, and we do swap a b here, like this swap is not going to be reflected. A and b are going to stay the same unless we have the and. So and is important because it says like this is by reference, and I want anything that's done on in here to be reflected on the original like variables, right? Does that make sense? So this is important. If you don't have this, it's not going to swap. Clear? I know it's a little bit confusing, but this is an important piece. I think in the slides you should have explained like what the and is for.
Yeah.
So yeah. Okay. Good. So now we did the swap function, and I think this is actually like probably important to have. memorize as well, swap, because it's pretty common. And I think question 6, it does include the swap as well. So it's good to know. It's good to know. So let's do the bubble sort. Swap if necessary, use function. Commit the second element and the third element, continue this operation until the max number is stored in the last index. Okay. I feel like these instructions are not clear. But anyways, we can explain bubble sort. So to do bubble sort, we want to loop over all elements. So I'm gonna do something like this. Int I equals 0 again, I less than size, I plus plus. Okay. And we can actually explain it here on the diagram. So you guys sure you never did bubble sort in class at all before? Because that's interesting. Like maybe is I don't know, but like it's a little bit new. Anyways, so we have an array. It has 1, maybe like let's start with 3, and then it has 1, and it has 2. Okay. So bubble sort, we're going to pick the first element. Okay. Compare it with the one after. So let's do it. So compare it with the one after. Is it bigger than the one after? If it is, then we're going to move it. So in this case, 3 is bigger than 1. So like we pick each one of these, and then we compare it with everything else. And then we pick this one and compare it with everything else, and so on. So we pick 3, we compare it with 1. If it's bigger, we move, we swap. So it's going to be, the new thing is going to be 1, 3, 2. Okay. And then we're still looking at the 3. We're going to take the first element and push it all the way to the end if it is the biggest, or like move it to the last place it could stay at. In this case, it's the biggest number, so it's going to go all the way to the end. So it's bigger than 1, it's going to move. It's going to like think of it as the biggest number. It's heavy. It's falling down to the end of the array. Okay, so it's falling down to the end. If you think about it this way. So 3, it moved here, and then it's going to move here because it's bigger than 2. And we're going to end up with 1, 2, 3. Now this is sorted, but we need to check again. So we're going to start from 1, and we're going to check, can we swap here? No, 1 is less than 2. It's in the right place. And then we check, did we swap? Like in this, like for 1, for this number, did we have to swap it? In this case, we didn't have to. It was already sorted. So that means we can stop now because there was no swaps done. So the way we do this, I know it's a bit confusing, but let's do it in code. Maybe now it is going to make sense. So we're going to have a Boolean. It's going to be swapped. Did swap. Okay. Did swap is going to be false. Okay. Initially, it's going to be false. And then inside, we're going to have another loop. So int j is equal to 0, j less than size. And we're going to stop at, like we don't have to continue all the way. We're going to stop at I believe. Or we can continue like this for now. Okay, here we go. And we're going to check. So for every element, so now we're looking at one of the elements, like maybe the 3 here, and we're going to loop and check it or compare it to the ones right after. If it is bigger, it's going to move up. So I'm going to do if array I is bigger than array j. If it's bigger, then it should be, it should be, let's see, so this is going to be one second. Let's actually confirm this. Okay. Okay. So this is gonna go all the way till array j minus 1. And we're gonna check if array j, because we don't wanna like check the, we wanna stop here, right? We don't wanna check here because there's nothing after to compare with. So we wanna stop here at this point and compare with the one after, and that's when we're done. So let's do this, and we wanna compare with the element after me, so j plus 1. And then we can swap. So if it's bigger, then we should swap these two. So I'm gonna swap array j and array j plus 1. Okay. And then if there was no swaps, if no swaps, and like actually if we do swap, we want to say that we did a swap, so swap is true. And if no swaps, if we did not swap, I want to break. Okay, so when I end, like stop the outer loop if we did not swap, because if we reached a point like here 1 2 3, we're gonna like, now this is the inner loop, the one with the j, and if we're looking, if we took the one and we're like trying to check there's no swaps here, that means the whole thing is sorted. And I think it should continue this operation until, actually this question should have more details. I don't think it should be viewed this way. But like we know how to do it because bubble sort is like a generally popular algorithm, but in an exam, I think he should give you more details. Now, if we do this, let's see if we run this, what happens? Here we go. Can you see this? So we had the array before the sort 8 2 9 2 3 4 7 3 9 2, and then after the sort we had it correctly sorted 2 2 2 3 3 4 7 8 9 9. Please feel free to ask questions. I know that this one is probably the most difficult. So like any specific part that you did not get, and we can go over it, especially in the bubble sort.
I'm not like exactly sure, like what does J represent?
So, okay. So usually when we loop over an array, we use I to represent the index I, but since now we have a nested loop. Did you guys do nested loops?
Yeah.
Okay, so because we have nested loops, we can't just reuse I here. So we used another variable, usually j, so I and j. Now in this case, I is going to, I means that we want to do this, like we want to do this thing inside. We want to do it like size times. We want to do it as many times as we have elements. So basically, it's actually pretty simple. So if we have an array here, so we have like 3, 5, 4, 1, 2. So what this says is, actually we're not, if you look in the problem, we're not using I anywhere, right? Like I just, like we don't even need it. It's just used for the loop, but we're not using it inside. What we use to sort is j. Like here, we look at the element and the element after it, and if it's bigger, we swap them. But I is just used to determine how many times we should do this thing inside. So the outer loop, so we have two loops, outer loop with the I and inner loop with the j. Outer loop with the I and inner loop with the j. So the outer loop is saying if we have 5 elements, it's literally saying this. If we have 5 elements, so size is equal to 5, then we need to do the following 5 times. The following, we yet have to talk about the following, but it basically repeats whatever is inside here 5 times if we have 5 elements. And that's how this sort works. If we have 5 elements, we're going to do something 5 times. What is it that we're going to do? We're going to pick the first element in the array and move it all the way. So do we have like a laser here? Usually there's a pointer. Okay, we don't. We're going to take the first element and move it as far as we can, right? In this example, 3 is less than 5, right? So it's gonna stay where it is. Like nothing is going to change. Now, wait a second. So we did swap if array is bigger than 3, 5. Array 5, this is let me think about how can we explain this here. So 8, for example, it's larger than 2, it's gonna move, it's gonna be pushed here. Now if it's not, then okay, cool. So we're going over the 3 and we're gonna see, can we swap it? Can we swap it here with the one after? No, we cannot. So that means 3, it's probably in the correct place. Now let's move to the next one. So we're here at 3. Let's move to the next one. 5. Is it bigger than the one after it? Yes, it is. So we should move it. Right? So 5 should come here. Oops. So 5 should come here and move. Now we are still with the 5. So now like J is pointing, J was 0, J was 1, and now J is 2. Now is 5 bigger than 1? Yes, it is. So it's gonna swap. Okay. Now J is moving. So like we're swapping and J is moving. Is 5 bigger than 2? Yes, it is. So we're going to swap that again. 2. Here we go. And this is one iteration. Like now we reached the end. This is one iteration of the outer loop. Okay. Of this one. This is the first iteration. So this whole thing, 5 made it all the way to the end. That's the first iteration in the outer loop. But we completed one inner loop. Now, how do we know when to stop? We have this thing which says if you pretty much if you went over the entire, so like if you check the whole thing, so you went over this and this and this and this and this and this and this, and you haven't done any swaps, that means that everything from the beginning all the way to the end, it's perfect, it's sorted. And pretty much just like stop sorting because you're done, right? So in this case, we did indeed like 5 moved a couple of times. So because it moved, we set swap to true. So because 5 did swap, so that means we should continue. Like we did swap, so we should not break. We should not stop the outer loop. We should continue because maybe there's more sorting to do, which is true. In this case, we're gonna start again. So let's actually do this. We're gonna start again at 3. And ask ourselves, is it bigger than 4? No, so we're not going to swap, but we're going to move to the 4. Is it bigger than 1? Yes, it is. So we're going to move it all the way here. Okay, and then again, we're going to ask ourselves, is 4 bigger than 2? Is it bigger than 2? Yes, it is. And we're going to move it. We're going to move it here. And we're going to ask one last time. Is it bigger than 5? No, it isn't. So we shouldn't do a swap. And we're done. Now we ask ourselves, did we swap like this round of picking stuff and moving them all the way to the end? Did we swap things? Yes, we did. The 4 moved a couple of times from here to here. So that means there's more work to do because we did swapping, so there's more work to do. Things changed, so we need to look one more time, and that's where we go all the way again and again, again, and every time the biggest number from that like region, it moves all the way to the end in its right spot. I know that's a lot, but does it make a sense? Make sense a little
Yeah,
bit?
it does.
Okay.
But okay, just one question. Couldn't
Hmm.
we have G as I plus 1? Isn't it the same thing? Like, and then size just stays the same.
No, no. So right now, in this case, we did first of all, why did we do size minus one? Because J is responsible for what? For swapping. So it's responsible for swapping an element with the one after it. If the like the previous element is smaller. So if one is smaller than two, then J is gonna be at maybe one. Let's use like different numbers. So three, it's at J equals zero. So let's actually type it. So J equals zero. Make it smaller. So J is equal to zero. That's three, and J plus one is equal to one. Equal to one. Okay. So J is gonna check. It's meant to like go all the way three, one, two, four only. Like we can't. So it's gonna be here. That's a value for J. J is gonna go cover three, one, two, and four till size minus one. If we do size, then it's gonna go all the way to five. Now, why not? Shouldn't we include the five? Like, shouldn't we like have size minus just size as we did here? No, because if we had size, the entire size included, then when we reach here, J is going to be equal to what? J is going to be like this index is 0, 1, 2, 3, 4. It's going to be 4. J is going to be equal to 4. And it's going to compare with the one after it, J plus, so J plus 1, which is 5. And we have no index 5. This place is empty. Like the last element has nothing after it. So we shouldn't be looking at it. We should be looking at size minus 1, like the element before the last element, and comparing it with J plus 1, which is the last element. But if we go to the last element and go to the check it with the one after it, which is nothing, we're going to throw an error. Let's actually like see this in practice. Let's remove this and run it. And I suspect we're going to get an error. So we did not, for some reason, let's see. Either there's two possible reasons why we did not get an error. Okay, maybe it's actually because like it ignores it. Like there's um, like if we let's actually try and print. I want to show you if we print array J plus one. Oops, not print C out. Then we'll have some element that is weird. It's going to be into the. I think it is probably this zero, probably. So array C out like this. Oh yeah, you can actually without printing, you can see it. You can see the problem. The array before the sort 222752, it had only 1 0, right? But after the sort, it now has 2 zeros. Now, where did this zero come from? It came from outside. So think about it. It was like here. It was somewhere here, and like because we included the last element, it got swapped with it. So we kicked the 7 all the way outside the array. We can't even see it, and we got a new number that was not part of the array. So this is wrong. There's a mistake here. Do you get this? So like usually C++ it keeps zeros in things that are outside our array. So it's like everything is nothing. It's zero. So there's some zero here. This array is size 5. The array is size 5 only. It's not 6. It doesn't include this here. But because we looped over the entire thing from 0, index 0 to index 4, it did not stop at 4 and 5. it did include j equal 4, which is 5, and it looked at j plus 1, which is index 5, which is the sixth element, which is actually outside our array. We don't like, that's incorrect. It did this, and it moved the 5 outside the array. Like C++ is not going to say no. Like it's going to let you move outside the array. And it moved the 0 inside. So the 0 got moved inside, and the 5 went outside, and we don't see it. And then the sorting continued, and 0 ended up all the way here. It's very subtle, but you see how like something like this caused an error. If we look here, let's see what happened here. So we also had 1 0, but we ended up with 2 zeros. You can see that all examples, they ended up with an extra 0 at the beginning because it came from outside. This one had no zeros initially. After sorting, it magically had a 0. So 9, which was the largest number, it got kicked out, and 0 came in at the beginning. Do you see the problem? -1. Let's compile again. Now it's correct. So if we had 2 zeros initially, after sorting, we still have 2 zeros. Okay, pick one, and we can do it. One before we end this. So 1, 2, we did 4 and 5. Which one do you want to do? Let's do 3. Looks interesting. Write a program that converts from 24-hour notation. Should we do 3, or is it easy?
Yeah, can we do it?
Okay. So I'm gonna have a new file. It's gonna be, let's actually copy this file. So problem 5, we wanna have problem 3. Okay, and I wanna do problem 3. Okay, this is problem 3. I just like copied everything in here, and like let's delete everything in here, and let's change this to 3, 3, 3, and run it. Oops, no, I think we forgot to save. So yeah, this is problem 3. Okay, so let's read the problem again. Let's understand it. So write a program that converts from 24-hour notation to 12-hour notation. The input is given as 2 integers. There should be at least 3 functions. So first thing, we have input, and it's given to us. It's 2 integers. So let's just do that. So the hours and the minutes. So I'm gonna do int hours and minutes. So we can call it minutes, and we'll let the user input. So we can have cout enter time as hours, then minutes, or like we can give him the format. So hours, minutes. This is the format he's going to use for the user. It should be friendly, and we do this, and we do cn, and it's hours, and then minutes. Okay, and we can actually print them out. So it's going to be hours, and then let's print the colon and print the minutes, and maybe add a new line at the end. So we can do this actually, or we can do the same thing as end line, but we're just gonna do this. Now let's see this, like try it out. Hours, minutes. So I'm gonna have like 23. So let's use the example they gave us. So it's 1425, which should become 225. So I'm gonna do 1425, and it prints it out for me. That's the time. Okay, we good? Now we need to do the processing, or the function that converts it back to 225. Okay. There should be at least 3 functions, one for input. Okay, so now we should have read the entire problem. It says the input should be done in a function. One for input, one to do the conversion, and one for output. So let's have something like this. So I'm going to have void input, and we're going to have a void convert for now, and we're going to have void output. 3 functions. Okay, and we want to move all of these into input. So enter time, and it's going to take in the input, and let's actually like pass them by reference. So I'm going to do hours. So when we do by reference, do hours, and we do minutes, just like we done before in the swap, right? By reference, so that the function that calls me, or the place that calls input, gets its own variables changed. So um, if we come here and say input, and we give it hours and minutes, okay, and we look at, so we can print hours, so same thing, minutes, and we can print this here. If we run it, we should get the same thing. Okay, I know I'm a little bit fast because we don't have time. So input is getting hours and minutes from the function that calls it. So from main has hours and minutes as well, and it passes them to input, so that input can ask the user for the input and change them. And any changes inside input are reflected back to us, so we can actually print them and see them, because we have this ampersand or this and sign, because it says these are passed by reference. Like the actual things, the actual variables, the original ones, should be changed, not their values only, or like don't take a copy of them and just change it here. Let's see what happens if we do x, and, and if we remove this int hours, so it's not by reference anymore, and we do this. This is critical. So if we do enter, and we enter, I assume that because it's by value, the original ones, hours and minutes, these two are not the same as these two. These are just like, these are inside this input function. Like even though they have the same name, we can actually change them, change it so you don't get confused. Maybe like make this input, call it input hours, and this is input minutes. It's different, okay? And I can do input minutes, input hours, okay? So I'm changing only the things that are passed to me, okay? But if we have the and sign here, it's going to change the original, uh, like, like, don't look at the names, like look at the actual variables. So if we have and sign here, it's going to tell it that I don't care about this name, I care about the original reference, or the original variable that was given to me. So if I do this, I think it's going to be 0. It's going to return 0, 0. And it did, right? Because without the and sign, CIN is going to change the local copies, or the copies of input of hours and minutes that are inside this function. It's not going to change the original ones. If I do and here, though, and save, and I run this, it should be working fine. Okay, are we good? I hope that makes sense. Now let's move to the conversion. Okay, so one to do the conversion and one for output. Record the AM/PM information as a value of type character. A for AM, B for PM. That's the function for doing the conversion. We have a call by reference formal parameter of type chart to record whether. Okay, so it's saying that the conversion function is going to have a call by reference parameter of type character to record whether it is AM or PM, but the function is going to have other parameters as well. Right now, it just right now it actually does nothing. So let's do the same thing. So it's going to have int, and we're going to say it's going to be by reference, because this function doesn't return anything. It actually modifies the things that are given to it. So let's have the input, and let's actually have something here. So I say time inputted is this, and we're gonna do the convert. So I'm gonna do convert. So let's convert the things user inputted. let's not say things, the time user inputted, have inputted. Um, so we're gonna convert and we're gonna give it what? We're gonna give it the hours and the minutes. Now they give us a clear instruction, so even if we don't know, they said that record the AM BM information as a value of type character, A for AM, B for BM, and the function doing the conversions, okay. So it should have a parameter of type AM or B, or like a character type, okay, best to it. So regardless, so it's going to be AM BM. I'm going to call it BM AM BM. Like it could be that or it could be that. And the type is going to be character as they told us, and I'm gonna call it AM PM, and it's gonna be nothing initially. We can have it actually set to nothing, an empty character. Okay. Now convert, the actual convert function, like now that we're calling it, let's actually write it, so implement it. So it's gonna have hours, minutes, and AM, PM, and they're all, most importantly, passed by reference, because convert is gonna modify them, and then we should be able to use them back here outside. Let's add a semicolon, and back here we should have the modified hours, minutes, AM, PM. They should be available to us. Okay, are now set by convert. They should be set by convert if we do everything correctly using pass by reference. And to emphasize this, I'm going to also, I'm going to change the name. So it's not going to be hours, minutes. It's going to be just like this to show you that this name is different. It doesn't have to be the same thing. I'm going to do input hours, and then another int. It's going to be input minutes, and the last one. What type should we have here? I'm not going to do this. You do it. So what should we have here? Here we're calling AMBM. What should we have here? What's the type?
Character.
Character. Okay. Should we have something after? Can we do this?
Reference.
Okay, excellent. Because if we did not add this reference, it's not going to change. It's going to remain like empty in the main function. It's not going to change no matter whatever we do inside. We have to do this. Now we can do this, and we can do the actual conversion. And for now, so we can test this out, let's print stuff. So let's say out. I want to print hours, like after converting, I want to print hours. Maybe add like a colon, and then add minutes, and then add AM, add AMBM, and we're going to have a letter M at the end, and then we're going to have a new line, okay? Because AMBM is just one character. This is one character, and it's going to store only either A or P. And then the M is just fixed. So M is always going to be printed. And that's exactly what they said here. A for AM, B for BM, and that's it. Also, you should take note of whether they ask you to name variables a certain thing. He doesn't do that here. But for example, down count num2s, he like requested that you call the function, write a function named count num2s. That's what he requested. Here as well, write a function named swap front back. So make sure that if he asks you to name variables a certain way, name them that way. Otherwise, he might deduct marks. Here, he doesn't like impose that restriction. So let's see, convert input hours, input minutes, AM, PM. Let's do the actual conversion. So how do we do this? So 14, 25 to 25. So if a number, so how do you do this? If a number is bigger than 12, it is BM, right? If a number is bigger than 12, so there's some condition, right? Let's do this. So there's two cases. If a number, if hours specifically, so if input hours are bigger than 12, okay, so that means we are in the 12 or like in the afternoon, right? So if we're given 14, that's a BM. If we're given 5, that's an AM, right? So in this case, if it is bigger than 12, then we want to make it BM. So that's one thing. So AM, BM, that variable is going to store the letter B because it's bigger than 12. Else, AM, BM is going to store the letter A because if it's equal to 12 or less, it's going to be A. Now we want to think about, so afternoon, like if it's exactly 12, what do we do? Is it, let's look at maybe like the calendar. So AM, BM time format, 12-hour clock. Okay. So let's look at this. Okay, we have a graph here. So 12 noon. Okay, so 24-hour 12 exactly is BM. Okay. Midnight 24 exactly, or like 00 is AM. Okay. So if it is bigger than or equal to 12, so afternoon, then it is B. If otherwise, if it's less than 12, anything that's less than 12 is going to be A, except I think the 24-hour. I don't know if he expects you to go into that detail, like these edge cases, but we can actually do this. So maybe something like, okay, we can do this for now and then test the like 24 later, because it's pretty much 00. It's maybe you can make it invalid in this program. Now, if it is bigger than 12, then we want to get it down. So like if it's 14, we want it to be 2. How do we do that?
Subtract 12.
Okay, exactly. So we can do something like input hours is bigger than 12. We're going to set it to B, but we're going to subtract 12. So input hours is going to be minus equal, or you can do it the long way, but I prefer the short way, minus equal 12. That's if it is bigger than or equal to 12. And the minutes, I don't think the minutes change, right? The minutes are going to stay the same. Yeah. So actually, we might not even need to pass it, but let's keep it. Let's keep it. Now I think that's it. It looks all right to me. Let's save. Let's run, and let's give it. We have an error, so it says line 22 empty character constant. We cannot have that. Okay, no problem. I'll remove it. So save it. It's complaining because it's empty, this part. So let's run it again. Let's actually like clear everything so you guys can see. And this is 14:25. And here we go. It received the time inputted and it printed 2:25 p.m. Now let's try something that's like so like AM. So 2:45 maybe. It got it right. So 2:45. It's an AM. Okay, and they want us to do the outputting in a function. So let's do just that. Let's copy this function here. And let's instead, so down here, I'm going to call output. And I'm going to give it the hours, minutes, AM, BM. And down here in output, I'm going to like do this, the same thing that we had before. Let's actually copy, so let's copy this because it's the same exact signature. We save this, and if we run this, okay, we have an issue. Hours, minutes, yes, we need to replace these. So I can do input, and I can do this input again, and I can do input again. Oh, AM, BM stayed the same. So yeah. So if we run this, 2:25, now we're printing through the output function, and we can actually add something like before this. So we can do cout time 12-hour time is equal, and like maybe like make it look prettier, and we can do 4:25, and that's it. So it gives the user the time he inputted, and it gives him the converted time. Now let's try something like 12. It's waiting for minutes, so 14. Okay, that's correct. 14 p.m. Let's try something like 24:00. And okay, so we have some issue here. This should be 00 a.m. We can add another condition to this, or I think we can you do it with modulo, like do modulo 12. Um, Either way, okay, so we can have something like here. Maybe we can have it at the end. So we can have a condition here. Maybe put this into an else if, and we can say if input hours, because 24 is a special case. So if input hours is equal to 24, we're gonna do something. Then we're gonna say input hours is equal to 0, and we can copy this. It's gonna be AM. And now, if we do 24, 12 maybe, this is gonna be 0:12 AM in the morning. Okay, so does that make sense? I hope it does. I think we solved, like, how many did we do today? We did 3 problems. So 3, 4, and 5. Now you guys have 1, 2, and 6. 6 should be good to practice like swapping and passing by reference and stuff. 2 should be good to practice loops. You should practice user inputs, practicing like conversions and units and stuff like that. Thanks, Jen. I'll look at the link. Sorting of array. 2 to do like conversions and user input and stuff, because it has like some nice restriction. Include a loop that lets the user repeat his computation for new values until the user says he or she wants to end the program. So maybe you can try this one. Compute the average standard deviation. Okay, that's like doing some math and making sure you can get the division right, getting the conversions right. So standard deviation, we should not use an integer, for example. We need to use a double or double or a float, so we can have like decimal points. You should take care of that. And then this one is good also as well to practice like arrays, indexes, and multiplication, that kind of thing. So yeah, any questions before we end?
I have a question.
Go ahead.
So for the convert function, why did you have the hour and minutes as like by reference? Because it works without them.
Does it? If we do, so if we do this, and
Does the character, like for the last one, yeah, like I kept the reference, but just for the...
but it doesn't work.
I don't know, like for me it works, but I just kept like for the AM, PM, I kept the reference. And I removed it.
Then it worked because you gave it a correct example. So if we do and here, and we do this, and we give it, for example, 225. So
No, I gave it 1425.
let's see. So 1425. But then this is incorrect. It should be 2.
Yeah, it gave me 2. I don't know how it worked, but
No, how did it work?
I don't know.
It shouldn't work.
Okay, I'll check.
Probably there's something wrong with the code, but no, it shouldn't work. So when you convert like anything without reference, anything that you do here is not going to be reflected back in main. So now so in this case 1425, it's bigger than 12. And when we do input hours and we like subtract 12, it's going to be only inside this. It's not going to be like moved to main. And when we output it, it's going to stay 14. It's not going to be 2. It should be 225. So in this case, I think Passing by reference is important, it's critical. Also in the input, so in the input, if we don't have pass by reference, it's not going to, like if you try removing the and from here, it's not going to be reflected in main, and whatever the user inputs is just going to be stuck here. And when this function ends, it's خلاص, it's destroyed. But in main, it's going to remain empty, just like as we've seen. When we remove these, the input becomes, like if we remove these, the input becomes just 0 and 0. So we can do 25, it's going to be remain 0 and 0. That's it. So any other questions? Thirdly, Khadija.
No questions.
Okay, was this use? No questions either? Okay. Was this useful? Did you like learn something new, or was it more confusing, or like I want to hear some feedback?
It really helped a lot. Thank you so much.
You're welcome. You're welcome.
Yeah, it helped. It helped.
You're welcome. I'll be posting the solutions. So tomorrow, inshallah, tomorrow I'll be posting the solutions to all of them. So like this one, that one, and 5 and 6. 6, I mean. And actually, I'll be posting the ones we solved today now, but tomorrow I'll be posting the other ones. But you guys like don't rely on it, because here, like sometimes if you just like watch or like look at the solution, you think that you get it, or like okay, you get how it's done, but once you're put in front of an actual problem and you try doing it yourself, you get stuck. It's like a complete mental block. So actually go and try to like solve these on your own. So the ones we didn't solve and the ones we just did, try to redo them on your own, and like see where do you get stuck, what things do you struggle with the most. And inshallah, I think if you do this and review, like this is pretty much covers most of the like I think midterm requirements. And if you covered like the slides in terms of theory, you should be able to do the multiple choice, and inshallah it's a full mark midterm. It's not actually hard to get full mark in programming one. So yeah, any questions before we end this on a good note? I can actually stop recording.